So continuing on, we set the y parametric equation equal to 0 and the z parametric equation equal to 0, because that's where we're going to cross the x-axis. Then we just have to solve for s and t. So I'm going to start with solving the y equation. If I've got negative 2 plus s equals 0, then s must equal positive 2. Next, I'm going to solve the z equation. So I've got negative 2 plus 4t plus 3s, but I know what s is already. S is 2, and that equals 0. It's a little bit of combining the two equations. So let's add this all up. So we've got 6 minus 2 is 4. So I've got 4t plus 4 is equal to 0. Solve for t. We're going to move the 4 to the other side and divide by 4. We get t is negative 1. So what I have is s equals 2 and t equals negative 1 at the x-intercept. But nobody's really interested in s or t. What people are interested in is what is the x-intercept itself? Like, where is that point is what we want to know. So to do that, let's go back to our full plane equation. What we're going to do is plug in s and t into our full plane equation. So plug in s and t. So what will we get? We'll have x, y, z, that's our general plane equation, is equal, I'm going to sneak it down to the next line here, to 1, negative 2, plus t is negative 1. So I'm going to toss in that negative 1 for t, times the first vector, 1, 0, 4, plus my s is equal to 2, times my next vector, 1, 1, 3. Okay, when I add up the x components of that, I get 1 minus 1, so 1 plus negative 1 here, plus 2, which is equal to 2. When I add up the y components, I should get 0, so negative 2 plus 0 plus 2. Nice, gives me 0. When I add up the z components, I should also get 0, negative 2 minus 4 plus 6 is indeed 0. So right there, that is my x-intercept. And sorry, I should make that a point, because that's just the point where we cross the x-axis, not a vector. So that point right there. Okay, the last thing we're going to do with the vector equation of the plane for now is to actually create that equation from 3 points. So I've given us 3 points here, A, B, and C. So let me just draw A, B, and C, not on an axis. I'll just imagine them being here, here, and here. So A, B, and C. You can see that if you had 2 points, just A and B, that would define a line. But if you have 3 points and they're not all parallel, not all in a line with each other, if C is kind of over here on the side, then what we get is a plane. And so a plane can be defined by 3 points, or it can be defined by 2 vectors, is the other way that we just talked about. So we're going to get the vector equation of the plane defined by these 3 points. Remember, in general, our vector equation looks a bit like this. So x, y, z is equal to a point vector. So this is a vector to a point. And then plus t times a slope vector, or a vector parallel to the plane. So this is our slope vector. And then plus s times another slope vector not parallel to the first slope vector. Cool. So a point vector, well, that seems really easy to get, and it is. I have 3 points, so you can literally just pick your favorite one. So maybe I'll grab point A. That would be a great choice. So just choose a point here. Pick any point. For the slope vectors, all I have to do is subtract 2 different points to find a vector. So maybe this vector could be b minus a. And this vector maybe could be c minus a. They don't have to be that. You could also do maybe a minus c or b minus c. Those are all possibilities as well. Let's try figuring out then what these individual vectors are. So b minus a, I'll do that in a new color here. So b minus a, that's vector ab. B minus a is going to be 4, 1, 1, minus 1, 0, 3. So 4 minus 1 is going to be 3, 1 minus 0 is 1, and 1 minus 3 is negative 2. So that right there should make it a vector. That is my vector AB. Now I also want to know some other vector in this plane, so c minus a seems like a good one. So let's do vector AC, which is c minus a. That's going to be 2, 2, 5, minus a again, 1, 0, 3. That gives me the vector 2 minus 1 is 1, 2 minus 0 is 2, and 5 minus 3 is also 2. Check before you go any further, are our two vectors that we found parallel to each other? Because these have to be not parallel. They're not parallel. You can tell this is not a scalar multiple of that, so we're good. These are great vectors that we found. All right, so let's put that all together and get our vector equation of this plane, x, y, z. It's going to be equal to our point vector. So pick any point you want, equal to our point vector. Pick any point you want here. Maybe I'll pick point B. It looks like a nice one. 4, 1, 1. Plus a scalar multiple, so t, times one of our slope vectors. So maybe this one, 3, 1, negative 2. Then plus our next scaling term, the s, times our last vector in the plane, 1, 2, 2. And there we have an equation of a plane in vector form from 3 points which define that plane. Thanks for listening.